that case, we can move on. Let's move on to Google's neural machine translation. We are going to bring back attention because we saw that it's going to fix the issue with long sentences. And we are going to use word piece, which is an extension of byte pair encoding. It's very similar to it. It's an assignment for you to watch this video. It's one of those papers that you're going to throw whatever that you have at a problem just to be the state of the art, because you want to use your algorithm in production. And let's try to do that. In the meantime, while I'm giving an overview, you can think of questions to ask. We are going to have encoder-decoder architectures using RNN. We are going to introduce stacks of LSTMs on top of each other, and we are going to introduce residual connections. So that's about the architecture. We saw that attention mechanism is important to actually deal with the sequence length. We are going to bring that back in. We saw byte pair encoding and the tokenization process matters. We are going to bring back or bring in another version of byte pair encoding. It's very similar, just a little bit different with word piece. For instance, if this is your sentence, and if you look at the word pieces, the jet is going to decompose it to two words. Maker is going to still remain a single word. The beginning of that word, FE, is going to be one portion of feud, and the other one is going to be UD, etc. And then when it comes to merging, anything that has this underscore cannot be merged with anything before it. But the other ones you just merge. For instance, ET is going to merge with J, and it's going to give you jet when you're actually doing your translation later on. So these two things mattered, attention and tokenization. We modernized that. We brought in word piece. What else? In the end of the day, you are looking for an algorithm that is going to do its best when it comes to a performance metric, maybe blue score. But when you are doing maximum likelihood estimation, maximum likelihood is correlated, but it's not exactly blue score. You're just making your translated sentences more likely. You can actually modify your objective function to bring back more of the concepts of the blue score inside your objective function, so that what you're optimizing for is actually what you care about in the end, in terms of your performance. And glue is a modified version of blue score. Because blue score is for your entire data set, you need to modify that score so that it takes as input pairs of sentences. It's not for the entire test data or validation data, but actually for a pair of input-output sentences. This is not going to be differentiable, and whenever your objective function, the signal, the feedback, the reward, or the cost that you're trying to optimize is discrete, it's not differentiable, a good idea is to use reinforcement learning. So we are going to cover reinforcement learning later on in the course. Don't worry about that at this point. And your objective function is going to be a mix of a hybrid version of maximum likelihood estimation and reinforcement learning with some control parameter. This is a hyperparameter. Okay, so far so good. Then it comes to putting your model in production. You want to actually have a Google Translate that is going to be really responsive. You type in your French sentence, and then it's translated into English almost immediately so that the user doesn't notice. These neural networks are huge, and the idea of quantization is to actually make them operate faster while keeping the same level of performance. So you're going to quantize. In the first part of the course, we actually spend a lot of time on small models, how to make larger models smaller, how to prune weights, how to quantize your weights. And here is those techniques applied to machine translation. First of all, your variables need to be quantizable. And what do I mean by that? They shouldn't be unbounded. So during training, you have to control them so that your variables, your weights and biases are not going to exit a predefined threshold. And as soon as that happens, you can just divide this interval into perhaps 256 grid points. And then rather than having a float, you have a quantized integer representing your outcomes. So you quantize your model, your weights and biases, you quantize some of these operations for instance, addition and multiplication. And then your model is going to end up being much faster when it comes to production. There is also another change when it comes to decoding. You are going to penalize the length of the prediction because we saw that our language, our translation have a bias towards shorter sentences. So let's try to unbias that. And the other one is trying to diversify when it comes to paying attention to the input. And this is going to modify your beam search. Any questions about GNMT, Google's neural machine translation system? And this is the first time that a neural machine translation system is going to stand on its own. It's going to be the state of the art, beating classical statistical machine translation techniques. It took a lot of effort. Any questions about this one? Was everything clear? Okay, perfect.